All right, well, we'll get started. People will probably trickle in over time, but as the day gets later, people kind of get busy or something.
Yeah.
Oh, this might be the smallest start. I haven't had two before. This classroom is closed at 11 p.m. I can't imagine taking a class till 11 p.m. That sounds pretty crazy. So today I'm going to talk about apparently a boring topic because nobody wanted to come in and talk about continuous integration, continuous deployment or development. The second part varies depending on who's asking the question more than anything else. Do you do CI/CD in your?
Not yet.
Okay. But you know what it is?
Yeah.
Oh, that helps.
Right now we just have, it just auto deploys whenever we push.
What could possibly go wrong?
We have a different repo set up for production. So we have the repo that we have for the course is our development.
Right.
And that's what we use locally. And then we'll push it to the remote, which is our personal one, and that's what's actually connected to AWS.
Right. So that goes up. Do you have like acceptance tests and whatnot before it goes into production?
Not yet, no.
Straight to production.
Yeah.
Yeah, all right. Fair enough. You'll get burned by that eventually, or you'll fix it before you get there. Hopefully, the latter. Well, all right. Then this won't be super exciting to you because you'll have seen what I'm talking about. So I'm going to talk about CI/CD pipelines. I'm going to talk about the things you can do locally, actually, that help, like get hooks. How you set up a pre-commit hook in your repo, and then how you can actually connect that into the work that you're doing for the capstone. So there we go. It's getting lonely. It's kind of like when you show up to. I go to a gym where it's group classes, and you show up to the gym and there's one person. Me. That's always a little intimidating. So now I have multiple people I can ask the question, how many of you are using a continuous integration, continuous deployment framework? How many of you know what it is? Okay, good. Well, it helps me to know what is and isn't known because I don't want to talk about things that you know. So I don't have to like explain the idea behind this. That lighting is terrible. It kind of makes the screen hard to read. Okay, so you've got some project. Have you done any CI/CD kind of work with it? Are you like automating the testing, doing those kinds of things? Because it's a good idea to at least start to explore that, because anything you do in the cloud is largely going to end up involving this kind of pipeline. It's very common, especially as the projects get larger and more complicated, to find that you can't actually test it very well. So literally people build this to run things, do as much testing as they can, and then they push to production, and often the push to production can be staged. The larger the project is, the more likely it is that you actually layer the exposure to the customers, to the outward-facing consumers there. Have any of you ever heard of a company called OpenTable? So OpenTable does restaurant reservations, and they manage restaurants. As an example, I have a friend who works at OpenTable, and that's a company that pushes to production all the time. And they are international in scope. And so when they push something, they do in fact have a staged pipeline where they'll push it to a small number of people and they'll make sure that it's working. In theory, Amazon does that as well, but as you might or might not have noticed, Amazon had a sort of religious experience about the dangers of using AI indiscriminately. So, but they're still laying people off, so go figure. So, since it sounds like everybody knows what this is, I'm not going to spend a huge amount of time on this. I'm just going to touch it briefly. for the people who aren't here but are listening to the video, continuous integration is literally a situation where every time you push, you get automated checks. GitHub itself, when you use the real GitHub service, has continuous integration built in to the platform. It is something that is available to you. If it's a publicly available repo, you actually get a fair amount of free resources available there. If it's a private repo, then you have to actually be, you have a much smaller number of resources available, but they'll sell you more. The GitHub that we are using, the enterprise deployment here at UBC for computer science, does not have GitHub Actions. They do have a GitHub that has GitHub Actions, but it's in the experimental stage. And so I have an account there. I haven't spent enough time playing with it yet. But if we had it, I would already be asking you to use it, because it is really useful to have that kind of automated testing. We were talking about building these tests, building these CCTs, and then, but you have to manually run them. The right discipline is to say, I commit something, it gets tested, I can't even submit it until it actually gets tested. But we can do some of that by using Git commit hooks. The really cool ones, you'll see it when you go to repos, the really cool ones, they actually have like little displays on their README page that tell you whether or not they're passing all the tests. That's literally where you see the red bar tests. So you want to see lots of green, not a lot of red. So in the continuous delivery arm, if the checks pass everything, then what they'll do is they'll actually roll to deployment. Like I said, this can become a more than full-time job for a group by itself, doing continuous deployment. But for the moment, we will just start on the easy end, which is where we try to catch as many of the problems as we can for something small like a capstone project. The reason that we do this, well, ever heard this one? It works on my machine. My usual answer to that, if I have a software engineer who tells me, oh, it works on my machine, I'll say, great, we'll just ship your machine to every customer. It'll all be fine. Often what happens is we build, and we don't even know we're doing it necessarily, but we build an implicit expectation of what resources are going to be available, how the machine is going to work. I can remember a long time ago now, it's been quite a while, we had a customer who reported that something was crashing. A very specific thing, it was crashing, and it required a machine with 72 cores. This is like 20 years ago, 15 years ago, a long time ago. Probably closer to 20 than 15 now. And even now, how many of you have machines with 72 cores? Right. And so this is like when it was very, very new. It was actually a 36-core processor with hyper-threading, so it looked like it had 72 cores. The customer in question made nonlinear video editing software. And we had written the toolkit they were using, but when we wrote it, the maximum number of cores that you could have in a machine was 64. So this is why I say, it worked on my machine, it's great, but you have a machine that's only got 36, or you've got 8 cores probably, or 6 cores, not 72. So literally, we had no way to even test it. And that is not uncommon when you get into broad-scale deployment scenarios. You know, you start building databases, you start building these large systems, no one has what you're actually deploying to. And that makes it really challenging. I'm going to revisit observability on Thursday because, you know, we talked about it before. This time I want to actually say, let's see where this is in process, because this is where the observability becomes really important. When you push something to a customer, you push it out to deployment, and it breaks, your ability to fix that is going to be gated by the observability you put into the system. If you can't see what's going on, it's going to be bad news. And one of the reasons I mention this is because there is a tendency for people to start using AI coders. AI agents will consistently minimize the amount of data they collect in observability, which is a perfectly reasonable solution when you have a stable project and you are dealing with a different problem, which is you don't want to save everything all the time. But when you are doing new deployment, you don't want to leave anything out. You want everything, because there's nothing more frustrating than getting into a situation where you have to give the customer a slightly different version because it's got better observability in it, because you're not quite seeing the information that you need in order to debug the problem. It will happen anyway, but as much as possible, I'd like to avoid that. So these are different aspects of the same problem. CI/CD is we're trying to actually push things out. When we do push them out, we need that information to figure out what it was in our CI/CD pipeline that didn't catch the error in the first place. Continuous integration, continuous deployment is only useful if when something gets by us, we learn from it and we build our system to prevent that from happening again in the future. So, with the CI/CD pipeline, the commits themselves are validated, verified. We catch the problems as soon as they happen. Even if you're submitting to a branch, it's not uncommon for people to expect your branches must also pass CI/CD. And it will tell you before you ever get a chance to pull that into the main trunk, into the main development line. If you have a good CI/CD pipeline, you find the deployment just works until it doesn't. But most of the time, it will actually work. There's lots and lots of systems out there that deploy, in some cases, multiple times per day. It's just a completely different model than the I'm going to build this whole thing, test it, and then release it to the public. This is I'm going to incrementally update it and keep updating it, which is kind of what you actually do during development. So you can use this during development. It is actually a good discipline. So in the real world, what actually happens is you push, we do static analysis, we make sure that it builds, we run tests, at least some sort of minimal set of tests, and then it goes to deploy. And if something fails, then we have to go back and we have to repeat this loop. At any point, if it fails, we stop. You have to fix it at that point. So, GitHub has GitHub Actions. These are their CI/CD tools. And have any of you used GitHub Actions at all? All right. So you're well kind at this, right? You know how to debug them locally?
Yeah, a little bit.
Yeah, good. Well, I'll touch on that a little bit here too. One of the hardest things about GitHub Actions are they don't always work when you push them to GitHub, and you're like, how do I debug the debugging tools? And honestly, the answer is you simulate them in your local environment, because you can actually, there's a guy who's built an entire framework that does the same thing as GitHub Actions. So you can build them on your own local system, get them working, and then deploy them, and then they just kind of work. So it's a YAML file here. So it's just a format that they use, and it tells you, when does that happen? When something gets pushed, what is it running on? That's going to be the container image it's using, and it tells you what actions it's dependent upon. It tells you what you have to do in order to run a set of tests. So this is clearly you're running, JavaScript or something because you're using npm. Our GitHub does not have actions. If you want actions, you can always set yourself up to use GitHub itself proper, and you will get actions, especially if you make your code public. If you don't have actions, but you want to use something that's comparable to them, the normal approach to this is to use ACT. This is actually the GitHub repo where ACT lives, and it implements GitHub Actions locally to the machine using Docker. So you do have to have Docker. How many of you have Docker? Okay, so about half and half. If you want to automate things, you should be using Docker. Docker is actually a very useful tool for this kind of automation, for doing things in sandboxes. I mean, it depends on what you're doing, obviously, but it is useful for sandboxing things, for putting your code into an environment where it can't really do anything too destructive because you get to control what goes in and what comes out. I routinely use it because I run a database locally, and I put the database inside of the container. Well, I put the database service inside of the container, and I put the database outside of the container. And I literally mount the storage location for the database so that it lives outside the container. The reason for that is containers are ephemeral. Containers don't have persistent state. When you turn the container off, everything's gone. It doesn't come back. So if you want something persistent, you have to store it either in a Docker volume, which is a simple way to do it, or you can actually mount an external storage location. This is a good way to play with GitHub Actions. I'm not going to spend a lot of time showing GitHub Actions. There's plenty of documentation about them, but the first time I had to start using GitHub Actions, I found that using ACT locally in order to get things debugged and working was very helpful. And then once your GitHub Actions are working, it's mostly they just kind of work. You'll occasionally break them because you add something to them, and over time you'll get better at fixing them. I don't have a better answer than that because there's no standard set of GitHub Actions. Everybody's GitHub Actions end up being very individualized. They're all bespoke. Githooks, on the other hand, run locally before you do commits and pushes. You don't need a server for that, you don't need any actions, and they're already there in your repos. Git will do these things. So you can automate the process of running the test before the commit can even be made. So if you want to make sure you're not breaking your own tests, set a Git hook. Git hooks are really nothing, well, they are nothing more than just scripts that run at specific points. Before you commit, after you commit, before you push, after you merge. So those are all steps where you can perform specific operations. Honestly, I think the only thing I've ever set up are pre-commits. And it's not to say that I'm trying to think of when I would actually do that. So pre-commits, for example, I didn't do this, and that I kind of regret it. I should have done it at the beginning of this class if I had a little more time. Is to automate the whole signing thing. So you just simply can't even check in code that isn't properly signed. If it's not properly signed, then it should tell you what you need to do. They're shell scripts, but I usually write Python scripts to go behind them because there's a whole Python package that you install and it just does this. But there's probably one for NPM as well. So by default, when you do git commit, it looks in .git hooks pre-commit, and if there's nothing there, then it doesn't run that. Otherwise, it will run that. It runs the script. If it exits with a 0, then you proceed. If it exits with anything other than 0, you failed, and the commit is rejected. So we stop. The hooks are already there. Actually, that's not, we didn't implement that. That's what I should have implemented, not what I did implement. I should have implemented the one that actually checks that, that automates all of that process so that it wouldn't have been so convoluted. It's funny, I looked at that slide and said, oh, the formatting is all fine. I didn't look at the content. I should have checked that content. All right, so, right. If you push an unsigned commit, you should get a reject. That's what should happen. That's not what's happening right now. That's what should happen. Right now, what's happening is it's getting rejected on the GitHub side, which is unfortunately very hard to debug. It's so bad that, in fact, last night they sent a message out saying that PRs weren't working properly. The people literally were not able to merge PRs, and so they were fixing it like 11 o'clock last night by updating the version of GitHub Enterprise that is running. And this was like to the whole CS faculty. It wasn't just like in this class. So it was affecting everyone. And I've seen a number of these little weird issues with our GitHub. I think it's a little bit older version. And you know what happens when you get old? You don't work right. So this is a very common kind of pre-commit hook, where what you do is you say, let me run it through my static analyzer, a linter. It finds the lint in your code, things that aren't bugs necessarily, but are stylistically undesirable, for instance. If the linter fails, it stops. How many of you are using AI coding agents? I can tell you from personal experience that you really want to be very careful with your use with linters, because the problem is that linters are very noisy. And they will fill the context window with noise really fast. I have actually seen, it's been a while, but I actually saw with Claude where it couldn't finish a commit without actually running to the end of the context window and garbage collecting, compacting, and starting all over again. That was not a pretty thing to watch. So I will warn you about that. They are very noisy. Sometimes, and the downside is if you don't keep up with that, if you try to introduce it late, then the files will be very noisy, and it's very hard for you to integrate that into an existing setup. It's not on the slide, but that is in fact what I have experienced myself. So, in the pre-commit framework, you just simply want to use the standard hooks here, for instance. Unless you really get sophisticated, you can just use standard GitHub pre-commit hooks. And that will do, let's see, this one, it says, use the pre-commit hooks, look for trailing white space. I don't know why people have a hard time with trailing white space. I mean, you're wasting an extra byte for 10 or 100 bytes at the end of a string, but okay, strictly trailing white space, that's fine. Merge conflict markers, that's a really good one. So if you're working in a team and you're doing merges and you miss the merge markers, it will catch that sometimes now, but this will also catch that. Verify that your JSON is correct. Who knows, right? Because you could have formatted something as JSON, but it's not quite right, and it might cause a failure down the road. Other checks you might put in there would be, don't check in your API keys. Oops. You know what happens to an API key that gets leaked publicly? It gets used. In general, the time between pushing to a Git repo and the time that someone discovers that you've checked in a password is about 5 minutes. They're actively scanned. People watch for this, and they actively exploit it. There are also white hat services that will send you emails telling you that you've checked in something you shouldn't have checked in. If you're using Python, I use UV, so I don't usually use pip, but you can use pip if you really want. I use UV add, but you can install the pre-commit hooks this way. That will install the Python package, and then that will install the actual hooks in your Git repository that will set up the pre-commit hooks. If you don't actually have a server, this is an approximation to CI/CD pipeline. So CI/CD will often run a linter. The pre-commit there is to do the same thing. The tests, run the tests, same thing. There's no real difference. Usually you're running exactly the same tests. The biggest thing that you lose when you're running this locally, unless you set it up that correctly, is that GitHub is actually spinning up a container. It's pulling your code into the container. It's running tests inside of the container. That's part of the whole CI/CD pipeline. But when you're running it locally, unless you set up the infrastructure to be able to push the code into a container and execute it there, it's not going to do that for you. So you have to do a little more of the work there. Build checks, you can actually do the same thing here in a pre-push, which says make sure that the code still builds, by the way. That's fine. You can push signing policy there. One of the things that's been getting me lately is that the committer email address and the email address of the key you're using have to be the same, or GitHub will freak out about it. If they're different, you will get a failure, and it's very hard to detect that failure, because you actually need to look at what the committer email address is, as well as an email address that's shown when you just do -- show headers, show signatures. You don't have automatic deployment with this. This does give you at least the first half of that, and it's useful. And how many of you are actively writing code for your capstone at this point? Nothing like waiting until the last minute. Sorry, it's okay. I'm not super surprised. If you're writing code, presumably you are running tests on it. Anybody? If you're week 11 and you haven't been writing tests for your system, I would be a little bit concerned. I mean, it's okay. There's no judgment there, but buddy, wow. So, all right. So the nice thing about this is if you're using this with your capstone and a pre-commit hook is there, then something I can look at this is, oh gee, I can see that you're actually collecting the evidence. And those hooks then show you're collecting the evidence, they're generating this kind of evidence. I mean, in some of the work that I do, I actually keep the test logs because, hey, you even set it up so you only keep the last 10 test logs. That's fine. Nothing wrong with that. But that way you actually have a history of these test logs. And of course, since it's Git, if you delete the old ones, they're still there. So you can always get them back. They give you a history of the evolution of your code. And sometimes that can be useful because you can say, when did that break? And you can go back and you look at the tests and you can see it broke 3 months ago. So one of the things that I did last term that I really didn't do as much this term is, how many of you are using AI? So pretty much everybody. So this is a prompt that worked actually pretty well. And if I wanted to know about how to use CI/CD pipelines, I could literally give this to my AI. Let's see, is this the whole thing? Or did it get truncated? Now I'm looking at this and going, copy pasted this from before. Let's see. I mean, I redid the slides because I wasn't happy with them, so. There it is. Okay. All right. I'm trying to remember where I put it. I'm going to find it last time too. Okay, I will leave it there. I will go back and dig that up because I had a very specific script and it looks like it might have gotten a little bit shortened. Although, let's see, 5 fundamental knowledge checkpoints, 7 phases, entry-exit criteria. Yeah, this is a summarization. So the point is you can actually ask your AI. You can say, I'm trying to figure out a new topic. I want to understand how that works. And this is going to annoy me until I find it. Yeah, I have a whole bunch of them. There we go, there's the whole thing. Yeah, I got truncated for sure. Then what I'm going to do great. I wanted bigger, it made smaller. Let's try that again. Come on. Okay. I want to capture that. There we go. That's better. All right. So, yeah, this is the full thing. Master. So you literally just take, there's 2 pieces to this, and I will post this because I did find it useful. So you want to know about CI/CD. So I want to know master CI/CD with GitHub Actions, and then down at the bottom, I change it here. There you go. So what I'm going to do is I'm going to say, okay, now hey Claude, please go off and do this. Claude's going to come back and it's going to say, obviously Claude knows a little too much about me. What's the primary deployment target? Let's do web services. What's your current GitHub Actions experience? Let's see. I'll see never written. Let's just do automatic testing. Oh, I see. It's drag to reorder your priorities. Okay, fine. Well, this is, I never had to do this before. Ask me questions on here. There you go. So it's literally, So the point that I was trying to make here, and I think it's doing a good job of that, is that the first thing Claude asks me is, why do you need to do this? Isn't this something you already need to know? And it's like, well, ignore that, Claude. Just tell me. Because, and I probably should have said that before, hey Claude, I'm doing a demonstration in class, and then would have actually had that context. This approach is useful as a general tool because in this particular case, what I've asked it to do is to help me learn a particular topic. And this is going to happen over and over again in your life, regardless of what you end up doing after university. You're going to find that you need to come up to speed very quickly on some particular tool or technology or concept or, let's see, it's actually showing up down at the bottom. It didn't actually get that message. Very nice. And I can't send it because it's too busy. Probably should have asked ChatGPT. It would have been much more solicitous than Claude. Claude can be a little too friendly sometimes. And this does work with all of them. Let me see if I can find a ChatGPT window. I can make a ChatGPT window. Oh, good Lord, really. I feel like I spend my entire life logging into things now. ChatGPT wants me to log in. Okay, now I'm going to do this all over again. This time I will go back and make sure this gets... Oh, interesting. It won't actually let me choose that browser. Well, all right. So everybody who's watching the recording will see something different than what we're seeing here in class, but I mean, it's the same basic idea, right? It's not anything. So the way that this particular prompt was designed is it's asking you for a general overview of this particular technology space. And then once it gives you that kind of background general information, it's explicitly set up to ask you exactly what you want to do with this. Now that's why the Claude prompt there asked me, oh, look at that, Claude has finally actually built a response. So the Claude prompt there was actually building, it was asking me questions. But here, I'll go back to the Claude prompts because now you can actually see. So it literally designed a little micro instructional thing. Now, if this is useful for you, then I mean, what I would probably do with it, for me, I would actually scan it, and I try to scan through it and see if there are things that I don't know or have more questions about. But I use this as a general way of orienting myself regarding a particular topic. I really should have picked something different than this, but I wanted to show you how to use it for this particular example. And I think this is important or useful because, like I said, it will happen over and over again. How many times in this class have you actually had to deal with a new technology? Yeah, I see people taking off their shoes now. Continue counting. But That's just a joke. I'm trying to be funny. More than once? Right. So this kind of a tool is in fact quite helpful for that. And I think that what will happen is once you get comfortable with this, you'll be able to ask these kinds of questions without having to use a structured prompt to do it. But it can be really useful. I'm trying to think of what would I ask that would be interesting. So I don't know, but now there we go. What do you want them to see? So now Claude is trying to help. Claude is always trying to help. You guys use Claude, right? Claude has this weird sort of helpfulness streak. All right, at any rate. So that was what I wanted you to see. I will get that full prompt. I'll put it on, I don't know. Should put it in GitHub, I suppose. I can put it on Canvas someplace, or I'll make sure that I make it visible, because I think that it is a good one. My original goal had been that that would be verbatim on the slide, but it appears to have been, Claude snuck in there and made it less verbatim. I asked it to fix other things on the slide because things weren't rendering quite right. It looks like it fixed everything. Okay. Let's see, can I? Oh, I can. Okay. So you can get little picture maps and everything in there. This is quite a long document. Unlike reading documentation, though, this also gives you the ability to go back and ask follow-up questions. You can actually say, that's not clear to me. Can you tell me more about that? Or, this isn't quite what I was looking for. I was looking for something else instead. And I think this is really cool because before I went to university, one of my interests was in how to individualize education to people. There was a guy who ultimately ended up going to where I did for undergrad because he was there. He had built this system called mastery learning. And in mastery learning, literally his observation was that students learn differently and they learn at different rates. And if all you do is use the same instructional materials to the same students, what you see is that there's a group of students in there who will excel initially, but then because of the way that you keep teaching, it doesn't allow the people who took longer to get the fundamentals to learn. And so what he said was, you want people to progress based upon their level of mastery, not based upon the rate at which you want to deliver the material. And so the concept was literally that in the ideal world, you would have tutors. You would have individual people who would work with you until you understood a concept. Because one of the things he found in his research was the people who took more time to learn initially often caught up and had better understanding of the material than the people who immediately grasped it. Because the people who spent more time learning and understanding it built a deeper understanding of the material. And the people who excelled initially because they did it fast were able to get a superficial understanding of it, but that superficial understanding wasn't enough to anchor later when you needed to have a deeper understanding. So what was interesting about that research was it ultimately found that students learn at different rates, and if you give people the right tools, they can be successful, whether they learn slower or they learn faster. And I really like that. And that's one of the things I think is great about this. This is creating exactly the scenario where you can learn things at your own speed and in your own pace with something that is as close to a personal tutor as you're ever going to actually get. And that's empowering. I mean, I know that people are like really afraid of AI right now, and there's a lot of concerns about it, but people were afraid of calculators too. How many of you have ever used a calculator? And how many of you have ever used a slide rule? How many of you use a typewriter? How many of you have buggy whips? How many of you have homes with pianos? At one point, believe it or not, the United States piano manufacturing was the largest business. It was very common. We'll have lots and lots of pianos. Now most people don't have pianos anymore. But, so that's cool. I wish I had a piano. I wish I had room for a piano. So use this. If you use AI properly, it will help you learn things that you wouldn't learn any other way. I think that the concern I have is that I see a lot of people who are like feeling angst because AI is replacing these entry-level programming jobs. And frankly, I can see why that feels threatening, but at the same time I would also point out that it creates an opportunity. And one of the reasons I do encourage people to keep looking at this is because wishing that it goes away is going to make it go away. But learning how to use it effectively means that you actually have a skill set that a lot of people who are still trying to wish it could go away won't have. And I can see it. I can see how, in my own work, using these tools, they're not perfect tools, believe me. You know, it's like I turn my back, and you can't trust that the tool is going to produce the thing right each time, but you can write tests. So it writes your code. What I usually do is I have Codex write my tests and Claude write my code. And they do really well at that. That works out to be a very good adversarial kind of pairing. You don't want Claude writing its own tests. I mean, no more than I want any developer writing their own tests. I mean, that happens sometimes because you're the only developer there, but it's not the ideal, and the reason is, why? What's the problem with writing your own tests?
Bias.
Right. The problem is that you have implicit understanding of what you want the code to do. Someone who's writing the tests doesn't have that implicit understanding. What they have is your contract, your agreement. You've said, this is what my code is going to do. And so they're going to write tests to make sure your code does what you said it's going to do, not what you thought it was going to do. Why is the capstone structured the way it is? Because the code is really not the most important. It's not the most important artifact of what you learned. The code is an artifact of what you learned, but the design is more important because we've already got AI that can code. But you know what? Their design skills aren't the greatest. They have kind of this limited capacity. They cannot fit everything in all at once. And that's something that humans are actually better at right now. Humans are also better at remembering things. Claude's great, and it remembers weird things at times, but it doesn't remember things consistently. And that's a limitation of that architecture. So I can use Claude to write code, but at the same time, yesterday I found out that Claude had decided to take an idea that we talked through and we designed, and it changed it somewhere along the way. So it wasn't what we agreed to. And once I caught that, I corrected it, and we went back, and suddenly, oh, gee, look, the thing that we're building is way more interesting than the other thing we built. And that happens, and it will happen. It's not because the tools are evil or malicious. They're working within a bounded environment. They have a finite amount of memory, they have a finite attention that they can spend, and it's like when you're studying for finals, you focus on the next final exam, don't you? And as soon as the final exam is over, the next day, your brain immediately starts to forget it because it has served its usefulness. So, if you're studying for a final, for an exam tomorrow, and I ask you about the the exam a week from tomorrow, you're not going to have any clue what I'm talking about. And a week from now, you're not going to have any clue about when I asked you about the exam you took a week earlier. And that's just normal. That's the same exact thing. There's only so much you can remember effectively. And human memory is actually quite remarkable that way. It really does a very good job of remembering things. It's all right. And I have been going on and on, but so let me ask you. Is this useful? Maybe, maybe not. Fair enough. Then I'll stop. I have shared it. I will put the full prompt on Canvas. Actually, I could do that right now. While you're all sitting there. Let's see. Let me do it right. Actually, put a page. There, all right. I can't do that. Okay. I'll do this after class. All right, it's almost done. I'll do it now. Almost done. Let's see. Link, course, pages. Done. It's on the home page. Well, there's a link to it on the home page. And great. Now we can go back to our normally scheduled lecture. So if you want to know about CI/CD pipelines in Git, you can put it into the learning prompt and it will give you, as you saw, a potentially very verbose and long conversation. You can ask it, you can change it. You can say, I really want a high-level summary, or I only want, a page. So you can limit how much it gives you as well. But you can go back and do that. So the idea now was to basically allow you to use this time, if you haven't already done this, to put hooks into your repo. You don't have to, I'm fine with that, but so I'll tell you what I'm going to do then. We've got bi-weekly check-in. On Thursday, we're going to talk about observability, because that's basically it. So what I'm going to do is I'll end recording here. If you want to work on getting GitHub hooks got GitHub hooks. If you want to work on getting Git hooks here, I'll be here. I can help you and answer questions. Otherwise, I will stop at this point while I'm behind.